Hey everyone, and welcome back to our Stiochiometry series. In this video we're going to talk about molar volume and concentration. Now let's start. What is a molar volume? Well, we usually measure the volumes of gases at room temperature and pressure. We denote it by RTP, and the conditions for room temperature and pressure are 25 degrees Celsius and 1 atmospheric pressure. Now, 1 mole of a gas at RTP is equal to 24 liters. So that's that for molar volume. Now let's do an example. Well, an example of that. Let's see. So determine the number of moles of 58.6 liters of carbon dioxide at RTP. So the question wants you to find the number of moles of 58.6 liters of CO2 at room temperature and pressure. So we said that a molar volume is what? Is 1 mole per 24 liters. We said that 1 mole of a gas here has a volume of 24 liters. So this is the relation. So how are we gonna find this? Well, he gave us a volume. So what's given? Given the volume. So 58.6 liters. And he wants us to find the number of moles. Well, simple. We use the relation. So 58.6 liters times 1 mole is 24 liters. And see how the units cancel? This is where the magic happens. If your units cancel and you end up with the right unit, that means you're on the right track. So this is how you check if you're right or wrong. So you get 24.4 moles. And voila, you have your answer. Now, let's move on to something we use in chemistry very frequently, and that is concentration. And concentration is basically the abundance of a substance divided by the total volume of the mixture. Now, what does that even mean? It means how much of a substance there is in a mixture. And it's a very common mistake that students divide by a volume other than the total volume. So be careful. You have to divide by the total volume. And we have a very famous formula for that. So concentration denoted by C is equal to the number of moles, which is denoted by N, divided by the total volume, so V. So C is equal to N over V. Now let's see an example. Well, calculate the concentration of 10 grams of NaCl in 200 centimeters cubed. Now, let's see. Well, the question wants you to find the concentration. So concentration is the number of moles over the total volume. Well, that's easy, right? So let's start. we need to calculate first the number of moles, which is N. And we said that the moles is mass over molar mass. And that's gonna be 10 grams over the molar mass of NaCl, which is 22.9 plus 35.5. And what do we get? Let's calculate this. So 10 grams divided by 22.9 plus 35.5, we get 0.17 moles. Now, let's see. So, to calculate concentration, we divide the number of moles which we got, 0.17, divided by the total volume. So this is the moles. This is 200 centimeters cubed, and what do we get? So 0.17 divided by 200, we get 8.5 times, sorry about that, 10 to the negative 4 moles per centimeter cubed. Now, usually concentration is not measured in those units. Usually volume is in liters. So if the question asks you to find the concentration in terms of moles per liter, what do? We have to convert this 200 centimeters cubed into liters. So 200 centimeters cubed, using the relation, is 1000 centimeters cubed per 1 liter, and we get 0.2 liters. And similarly, the concentration would be 0.17 divided by 0.2, and we get 0.05 mole per liter. So that's that for this video. So let's recap. We talked about molar volume, and we said molar volume is usually measured at room temperature and pressure, and 1 volume of the gas is equal to 24 liters. And we did an example over here, and then we moved on to concentration, and we said that concentration is how much of a substance is present in the mixture. And we talked about our favorite formula over here, which is C is equal to N over V. And then we did an example and we calculated the concentration of NaCl in 200 centimeters cubed of the volume. Now, that's that for Stiochiometry. In the next video, we're going to talk about balancing chemical equation. I'm so excited about that because it's one of the very important topics in chemistry. So stay tuned and good luck.